Alright, so hopefully this is recording audio. We'll see here in a minute. So, how many structures do we have? All we have to do, we have 3 Legos in our arsenal. 3 Legos. We have a sequence, a selection, and a loop. That's it. Everything we do is going to be based on using those 3 pieces. So, we went through, and one of the most confusing pieces is this idea of a priming input. So I want to make sure we've all seen this particular program and what we're talking about here, where we have the reason we have to use that priming input is because of this right here, where we have to input the number, but our loop always has to come up at the very top, that question we make that forms the loop. So that priming input is critical. And it's one of those that I had a hard time addressing and using myself. We have to have this idea that we get in, for example, in here, we get a number. Now, the other piece of this one is you heard about something called a sentinel value. So a sentinel value is the way we get out of our program. And in this case, we really are using that inputted number for 2 things. One, we use it to calculate an answer that we're going to show the result of. But it also serves as a way we escape that loop. It's a sentinel value. So it comes in here, and this is that abbreviation we use, end of file. So in our case, we'd probably make some mark that said, you know what, if you type in 999, the program will end. So this is where it makes that decision of, do I complete that loop one more time or not? If we complete that loop, so in other words, it's not end of file, we come through, we calculate it, and we get in a different number. If we don't get that second number or some way to change that, we are going to loop forever. We're going to be in what's called that infinite loop. It's just going to cycle over and over and over and over again until there's not any ability to get out of that loop. And sometimes we do that accidentally. But we always need to make sure that we have a way to change that value. Whatever we're basing our loop on has to change in some way. It's really easy to forget that. You've got your original piece in, and then that program just spins and spins and spins. Push it out of the way. So kind of going over a rehash of a couple pieces. We looked at structured and spaghetti code. And now, we want to look at something that's a little bigger. And I'm on slide 22, so I'm going to make this a little bigger just really quickly. So this is a program for washing a dog. Most of us have had a pet. We've had to bathe them. It's a pain, right? No? I have cats. Bathing them is more fun. Define life. No. You throw them in the shower, turn the shower on, keep the door closed, and they can't escape. And they've got to not do that like that. No, I actually have one that weirdly does like water and will actually climb into the shower, which is weird. Well, it's weird. So they do. So this program, a couple of things about it I want to point out. And in fact, I'm going to try this. So hold on to your horses. We're going to see how well this works. We're trying out, because we've had some weird networking things, we're trying to see if this will still work. So, I need to apparently change monitors. Oh, it's only showing me one screen. Alright, well maybe I can't do that. That's going to make me very sad if it does not show me that. I have a program called Desari that we use. Let's see if it will reset. Because of some of the network changes for things like the phones that are bringing out, I've been having a little bit of trouble connecting to it and actually having it display correctly. So, we'll see if it will actually show up on the screen here on top of what you're looking at. Well, it does that, but it's not doing it over the base image. All right. Go backwards. I may not be able to use it quite like I wanted to. All right. I was going to use this so I could point out on the screen so everybody could see it, but clearly we have a little disconnect issue still. The problem is it gets onto our wireless network, which is the campus controlled, and we have to translate it into this network, which I control. And so as they're doing some updates, we've lost some odd connection pieces there. But again, we start with a start and a stop. So this whole program could be think of as one module. Because think about this. What if I wrote a program that taught you how to take care of your animals? Maybe washing the dog is one part. Maybe feeding the dog is another part. Maybe taking it for a walk is another set of instructions. Because we have this idea of modularization, and we have the idea that these are structured, I can click these in, these start and stops, and I can put them into a much bigger program. So in this case, though, we have some modular pieces here. So we catch the dog. Easily enough done. But does the dog run away? Yes. Catch the dog again, and notice it comes back around to the very top of that loop. And so that catch the dog initially, that's that priming value that says we're going to catch the dog. Does the dog run away? Yes. Runs away again. And if it's been like some of the animals I've had, the dog will run away until they're so tired that eventually they're going to lay down and take whatever you have going on. So, we catch the dog, and so finally the dog doesn't run away. So in other words, we escape our loop. And so we turn on the water. And again, with the pets I've had, that's the sign that, holy crap, the dog's going to go run away again. But what I want you to notice is, did we really just take that, does dog run away, that loop, and we moved it down, and now we've expanded it and put some more items in it, right? So we added a turn off water. Does the dog run away? Yep, all right. Turn the hose off, catch the dog. And we catch that dog cycle down here is repeated. And that's literally exactly the same code. And when you look over here at the pseudocode, it is exactly the same piece of code. So we're already cutting and pasting and reusing things we have. So, eventually the dog gets tired, doesn't run away, and we get the dog wet, and we apply shampoo. Generally, that's the case for the dog to run away and go roll through some mud, hay, whatever it is. So, once again, we have this very similar module. So, although this looks complicated, when we actually look at what the pseudocode is, do you notice that we're starting to see repeats of the same thing? The computer does things very well over and over and over again. Because quite frankly, at some point, with some of the animals I've had, I got tired and said, you know what? We're out. We're done. I don't even care if this dog ever obeys again, right? So, this is a very structured, small example of some code we're going to do. But, again, while it looks like there's about 20 lines, notice how many of those are actually repeats in blocks of code that are the same. The catch the dog, while dog runs away, catch the dog, end while. So those loops are really the same thing. And we see them in a couple places. They're just snapped into place. And this is that idea of how we take something and we just add it repeatedly in to the same thing. So, everything we are going to do can be done with those three structures. Everything we do is those three structures. That's it. That's the entire class right there. You guys are all ready to go now. We have three things to know. It really is. That's everything. If you can reconnect those Legos in the right spots, then we're good to go. You guys can see that, and we can look at it. So this week, and I really wanted to leave a lot of class time so we can look at a couple of these pieces. We have two things that you really need to do, right? You have a test, a quiz over the book that you guys have all read, right? So there's a quiz over the book that you've read, the online book, the e-book that's available in week 1 for chapter 2. And everybody's read that, right? I should hear the sound of everybody nodding their head enthusiastically. It's pretty short chapters, and again, the price is really right. And then we have an assignment. So that assignment says we're going to do something with a couple of decisions or a decision of your choice. You're going to now go from writing a very small program that you did to conduct payroll last week to now you're going to have to amp this up a little bit. And you have a couple of choices. So, you need to create and submit a structured flowchart, and so I cut this out of the book just because it was there. So these say you do either one, but I want you to have to do both because I think both skills are important. And so we're going to look at what some of those things like a flowchart, because we haven't done a lot yet with it, what those look like. So these PowerPoints and some of the examples are a really great resource for you. And so you have a couple of choices. So a customer purchase, rock, paper, scissors, and deal or no deal. And I will tell you there is one particularly challenging thing. We all know how to play rock, paper, scissors, right? So here's the problem with rock, paper, scissors for you right now, and it'll hopefully get you thinking a little bit. How many things can you choose when you play rock, paper, scissors? So 3. So you can have paper, rock, or scissors. How many things can the computer deal with in a decision? 2. Oh. So this one becomes a little more challenging because of that. Does that mean it can't be done? Well, clearly it can be done if you've played some of the things like Call of Duty and other things now. We clearly have made it past the how do I make 3 decisions out of a binary. So we want to look at that a little bit, how we could solve that problem. We want to look at a flowchart and see what we can do there. So a flowchart has, so clearly it looks like I can't overlay it on top of the PowerPoint now for whatever reason, but I can do it on a blank screen, and so we can look at that. And you can see my magical drawing abilities. Of course, now it says it will let me, so whatever. Thank you, magical non-working tool. So, a PowerPoint or a flowchart has a couple of things in it. How do we start and stop a flowchart? We call them terminal symbols, and what does a terminal symbol look like? No. So, a terminal symbol is just that, it's that oval, and hopefully you draw it better than I did on that. So, your program's going to start and stop. So there's our start, there's our stop, and then anything in between is part of our program. Well, we do the same thing when we write the pseudocode because I always tell you to make a start and a stop. And that's part of that is so that they're the same when you look at them. So we have the same symmetry from one item to the other. There's my hideous handwriting you can see. So we have a couple of other symbols. So if I want to put data into a system, and I'm going to use a flowchart of some kind, what do I use for an input symbol? Not the triangle, not the square, the parallelogram. Now, it has bugged me forever why we don't have a symbol separate from input and output. But the reality is we use that for both input and output. We have a square that just says we're doing something. It's usually, we're computing, we're adding, we're doing something internal. We've already got the data. And then we have our diamond, which means we're making a decision. So data comes in, it asks a question, and then it either does yes or no. So I know that's pretty hideous on the handwriting, but I want to show you what some of those look like. So when we go back up, and again we go back up into this bigger flow chart here, we look at something like this, that's really all the symbols we're using. And this flowchart graphically says this is what we're doing. The pseudocode calls it out in more of a programming-centric logic. So these are exactly the same thing. And if I'm going to look at something, looking at this isn't bad at all because we can say, all right, we have the start and the stop. And we know that we're going to catch the dog. Wild dog runs away, catch the dog, end while. So that's really also, the catch the dog is that priming that input. The wild dog runs away, catch dog, and end while are the loop. So we can all see that. And then turn on water, that's another sequence. So let's think about an example. Let's think about an example that you guys have all had experience with, and let's see if we can figure out something very similar to it. Most of you just recently enrolled in school, right? Enrolled for some classes. So let's do a breakdown of that enrollment process. Let's see if we can come up with something very similar to that enrollment process. So hang on, while I go to this. All right, this ought to be frightening. My drawing skills. So we know that we're going to have a start and a stop, right? So this is going to be hard to draw it all in here, but we'll try. So we know we're going to have a start and a stop. So what's the first step for enrolling for classes? What do you have to do? Okay, so advisor. I wish I could draw a little smaller, but I can't. So advisor. What's our next step? Oh. So we'll put that as a compute, classes. Alright, so now we've got our list of classes. That was magic. We didn't have any questions. And you had already figured it out. What's our next step in this? So we have to log into Blackboard, or log into MyPSC. Okay, so now we're logged into MyPSC. What do we do? So we have to search for the class. Search. Can we search for every class all at once, or do I have to do them one at a time? Okay. So I'm just going to kind of go up here and just say, all right, so our loop, it's continuing down. So we search for class 1, search for class 2, search for class 3. Do we do it that way? Oh. So really, see if I can go backwards enough to make this make sense. We're really going to create a loop. So I'm going to delete out some of this so we can have a little more writing room. So really that search for classes becomes an iterative process, doesn't it? So I'm going to actually draw my diamond, and I'm going to call it EOF, even though we know it's end of classes. The first thing we're going to have to do is search for one class. So that's that priming input. Are we done with classes? No. So we're going to search for another class. So end of file. Sorry. EOF. I usually use EOF. So that is EOF. That's that shortcut we use a lot of times to mean that in some case we're going to exit out of that search box somehow. So here we've got, now that I dragged through it, it looks really sloppy here. We've got our diamond, and that's EOF, so end of file, and it's just kind of our shortcut that says we know that we're done with this search. So end of file, so this is our yes, and this is our no going back in there. So when you search, you're going to search the first time, and we all know that you're going to search for one item. That's that priming input right there. As I search for my item, I add it to my shopping cart, and we can do all those pieces in there. But I hit this end of file. And so what you don't see in the graphic interface is that there's some way to exit out of it. So this is the reality of how most systems work. There's some kind of thing that says, I'm done. So in this case, it might be search for additional class, yes, no. And you may even ask that question. So we abbreviate it with that phrase end of file to show that we're getting out of this loop some way. So we're going to talk a lot about loops and some other pieces. But for now, just trust me that we have some way to get out of that loop. We have something inside of there. We're searching, so we're adding a new piece. So you're inputting data. So the reality is we'd have a parallelogram and say input class number search or class name search. So we'd have another input in here so it can reiterate. So we don't have any limits yet on how many classes you could take. So there's a lot of things we don't have in here as protection schemes or anything. We're not looking at that yet. Because there are limits to how many classes you can take, right? I have had a student try to do 30 hours in a semester. It didn't go well. Before we implemented some restrictions, they had enrolled in all these online classes, and I think it was like 30 hours or 30. Yeah, it didn't go well for anybody involved. But it was that idea that we didn't have that limit in here. And we'll show you next week. We start in on showing you some additional protection features. Right now, I want you to see kind of that idea of how does a loop work? How does our start and stop work? So our loop, so if we were going to try to do this and make it a little more elegant, I'd have, well, that was supposed to be a parallelogram. You'd have an input. It'd cause a search on Blackboard. And then that would feed data into this question here. And that's our friend EOF of some sort. It would feed down to this identical structure here. We'd have an input. It would cause some change in my PSC. And then if we weren't in a file, this whole cycle would repeat again over and over and over. So we're breaking things down into smaller and smaller chunks is what we're trying to do. So can I take this module then, and can I apply some of the same concepts then to how do I go purchase books? Yeah, it's very similar. Input your class. I'm going to search, are we done with our books? So when we write a lot of these little pieces, we look at it in terms of how do I make this modular and reuse that very similar code. So our pseudocode for this, so we're going to have, obviously we have the start and the stop. So you're going to have input class, and then you're going to have some kind of search. And then you're going to start this while loop. And this is where it gets a little trickier. So while not EOF. So it's almost a double negative if you read that. So while not end of file. So in other words, as long as we're not end of file, this loop is going to continue. And then I need to indent, because that's how I show that it's a new piece of code, so input class, search for class. All right, and then end while. So in other words, some way to say, hey, where this loop is done. So notice I bracket that whole thing is really the loop right there. So once we do that, once we can snap in something then down below it. So it could end, maybe our program just ends, or it might go to another module where we actually search for books that's right there at it. That'd be kind of handy, wouldn't it? As soon as you enrolled in a class, it would push it out, and you could put your books right in a shopping cart right immediately at the same time. That might be kind of handy. We're not quite there yet, but that would be that idea of we have different pieces. So this could get as elaborate though as we wanted to. To get into MyPSC, isn't there a login procedure? Yeah. And we didn't look at that at all, so we're just kind of breaking it down to some kind of higher level rough concepts of how these are going to work. Does that make sense? Everybody going, no, it doesn't. This gets a little tougher this week when we start looking at it. That's why I want to make sure you had some class time to work on it for those of you that are on campus. And then I want to make sure that you guys kind of understand this. Where do I find examples? Well, that book is full of examples of code so you can see exactly what you're going to do. And then, because we know that this, and I'll point out this whole thing, is pretty horrible in terms of appearance, right? Apparently my drawing skills are really, really bad. So what I want to do is look at so if I fire up PowerPoint on a blank presentation, and PowerPoint's one of the many ones you can use. So can I use the tools? So notice there are shapes up here. Well, luckily there is a shape for, you can put in a square. There are rectangles, lines, so you can do all kinds of things in here. So PowerPoint might be one tool that you can use to create that PowerPoint or that flow chart of how things work. Word has some very similar characteristics. There are, if I go searching for it, you're going to see that we have a whole lot of things out there. I have used SmartDraw before, and it's actually a pretty decent program. The sample demo program, if they have not changed it, I always have to preface that because software makers can change things on the whim of a coin. It will let you do everything, but it puts over the top sample or, you're using a free trial. I don't care if you use that. Make sure you can put it all together into something like one big Word document. So you'll copy and paste it as an image in. Probably the best one is a program that is probably not going to show us in here called Visio. Visio is a great program, and in fact, by next week I should be able to give it to you free again. We subscribe to a program here that's changed names. It used to be Microsoft Imagine, then it was Microsoft Azure DevTools for teaching, whatever. Renewing something and going through the paperwork process with Microsoft is a long process. And weirdly, it expires December 31st when, guess what, nobody's here. So it's turned into a far more convoluted process to renew that than I intended. So usually there is an ability to use Microsoft Visio. With one, again, weird exception. Depending on which version of Microsoft Office you already have, you may or not be able to install the version that I can give you for free of Visio again when it's out. Microsoft has two different models to install software. They have what's called the install file or an MSI file version, which is what I can give you through our program. And then they have what's called Click to Run, which is the way the Office 365 and the latest versions of Office tend to be installed. And Microsoft, in their infinite wisdom, says, oh, I won't allow you to install both on a computer. So what a lot of people got last year was, when we tried to use Visio, was they got a notice that said, well, you'll have to uninstall Microsoft Office so you can install this Microsoft Office set. Working on it. We'll figure out a way around it. We haven't yet. Microsoft seems to have hundreds and thousands of software engineers designed to make your life as miserable as possible. But make sure when you turn that in that I can open it. So if you use SmartDraw, it's fine. I like SmartDraw. It's got a lot of really nice features. Or if you use PowerPoint, grab that image and pop it into, altogether this into like one Word document. So it's in one file. You can't put an image into a text file, but you can certainly put a text file into Word really, really easily. So the other way to do this, and I have had, if you use a program, there's a lot of them online, and what I ran into with some students online, they created this great flow charts, and they couldn't get them exported in any way because they didn't want to pay the $200 or whatever they wanted to pay for. So it was on screen. And I said, well, here's an easy way to do that. I'm not super critical of the fact that it's got a little extra blurb on it that says you didn't pay for that product in this one. If I want to grab that screenshot, if it's on the screen, Windows has a really great tool, and not everybody knows about it, and it's going to change a little bit. It's called the snipping tool. And notice it's all going to change because Microsoft, in their infinite wisdom, again, wants to make our lives a little miserable. But for now, it still works. And I can create a new snip, and I get to change what it looks like. So they're going to change it a little bit, but I can actually grab any or all pieces. I can even do some freeforms. Then I can save this as an image or copy and paste it right into a Word document. So it's another way we can get that template back out of something if you use it. So I am not going to force you to go buy some $200 tool. That seems kind of silly. There's lots of them out there. And again, you can do all of these. It just isn't as sophisticated using something like PowerPoint or Word and the tools that are in there. It doesn't do the like snap togethers, and it doesn't have all the symbols already predefined for you. But they're actually there and you can use them. So if I go in and I say I want here's all the flowchart symbols right there. So there we can have our decision tree. There's some we haven't talked about, but here's our input-output symbol. There's your parallelogram. And then, of course, with PowerPoint or Word or any of the tools, you can actually then text and write text inside. I am also okay if you have really good graphic skills or you have the templates and you want to draw this out on paper and capture an image of it in a text, as long as I can read it. I am fine with that. So if I did this on a white sheet of paper and I captured an image of it with a camera or something else, you can insert that into a Word document. Okay. But if your drawing skills are like mine on paper, I would prefer the electronic method. But I want to see more, not so much the neatness of your drawing, I want to make sure that you have the ideas of how we're going to do these different items. So you are free to pick any one of those. And again, I probably scared everybody out of trying the rock, paper, scissors. It just really, the reality is what you have to do is take a second decision. And so you're essentially nesting one decision inside of another one, similar to what we've done actually in the PowerPoint. So, think it through. Sometimes our brain overthinks. We don't want to do that, but break it down so that you can understand that business process. What happens if you use that one? What happens if you're taking a salesperson, how do they make decisions? How do they decide what the payment type is? So we do that, quite frankly, by breaking it down into binary decisions, don't we? So we ask people, think about it, how do I ask people yes or no questions? Is this going to be cash? Yes or no? Is this going to be Visa or MasterCard? So that way we can break down a multiple step process into chunks that we can actually deal with. As of right now, we don't have the ability to process in one step something that says, is this going to be cash, charge, MasterCard, or gold coins? If you had a 4-step decision, we don't have the way to process it all in one step. And even when we do get some tools that will allow us to, on the surface, do that, on the back end, at the very computer level, we're still having to take that in yes or no, 0 or 1 steps to make that decision. So this assignment is going to take some time. It's going to probably cause you to pull out some hair if you have any left, unlike me. There's none left to pull out. And it's really the first time we've made you start thinking about that. So flowcharts are used a lot of times in business when we analyze a process. So when we have changed our operation of how does enrollment at our campus work, when we've made changes to that, we look at that flow of information and we build flowcharts. And we really do look at that and say, all right, how is this going to work? It gives us that ability to model what's happening in this case, the admissions process or the enrollment process, and we can model it and we can see what's going to happen, and hopefully we avoid as many flaws as possible. Now, are we ever going to be perfect in any of those? No. But when we have done it in the past, what we found out was students had to go in some circular loops to do things. And we still do some that I think are kind of truly odd. So if you set out more than a semester, we make you go back in and reapply. But instead of pulling all your data existing, we just hand you a form that you have to fill out. But the thought is, I would think, that we could pull that data already from existing, and you simply check at the box, yep, I really do want to re-enroll. Is everything correct? Yes, I don't need to change anything, and move on. You might have to change an address or something else like that, but it shouldn't be the process that it is. And so as you're looking at processes, try to break them down into smaller pieces. All right, any questions? Anybody's head hurting yet? The assignment doesn't sound bad until you start breaking it out. The other way you can do it, and sometimes it's easier to sketch things out on paper first, and then create the flow chart. Sometimes those are an easier way to do it because you can change things in your brain pretty easily that way. So I love paper, and I hate snow. How about that? Anything else? Any questions? Going once? For the good of the order, going twice, going 3 times. Sunday at midnight, correct. That way it conforms. All of the online classes end on Sundays at midnight, and that way we just have everything on a consistent schedule. I would change it up if I could, simply because that means Sunday becomes everybody who waits until Sunday at 8 o'clock sends emails, and I can't necessarily always get to everybody's email and answer and respond. And it also means, in this case, I have this semester 7 classes or something crazy. So, makes life a little more. So Sunday night, my wife just goes, oh, I won't see you. You're going to be down in your office the whole time. Very sad. Because then my wife leaves Monday and comes back usually on Friday. Usually, dinner I do not miss. But I'm usually up till 1 or 2 o'clock in the morning or later on Sunday night. So, Monday mornings, if you see me and I haven't had coffee, no, you don't want to see that. It's, as my wife calls it, the anti-murdery juice. Anti-murdery. It came off of a meme on Facebook she saw. So. My wife is the anti-coffee, can't stand coffee. So I usually don't drink it around her because even the smell she doesn't like. I know. It's her one flaw. And so I don't drink coffee around her normally. Monday mornings are usually the exception if she happens